So everyone, let me go ahead and welcome you. Divers, non-divers, you've all been very enthusiastic supporters of our marine life. And tonight we're going to talk a lot about marine exploration. We're super honored esteemed speaker for tonight's webinar, Megan Cook. And, she brings a wealth of knowledge. We were just flipping through some things, and her dedication to advancing of the ocean is so appreciated. So I'm going to just turn it over to her, and just to remind you can put them in the chat, or you can raise your hand, and we'll go ahead and answer them directly throughout the presentation. All right. So Megan, the floor is yours.
Thank you so much. And thanks everybody for coming. I really appreciate the chance to tell some ocean stories tonight and share a little bit about the world beyond where we often get to go with diving as a technology, and talk about the deep sea a little bit. However, you should all go diving this weekend. I'm zooming in with you from Washington State, where the visibility is not 20 feet off the beach and the water is not 62 degrees. So please take advantage if you can. That sounds absolutely incredible. And I need to plan myself a winter trip down to Catalina to take advantage. I'm Megan Cook. I use she, her pronouns, and I have a couple different hats that I'm here to share with, but I work for a team called Ocean Exploration Trust, which is a nonprofit organization, works all around the world. And we work on this challenge, that the ocean that we love, that keeps our planet alive, that keeps this entire world thriving in the way that we know, we have a lot of questions still about what we know about the ocean. And they may have heard this fairly unbelievable stat, 95% unexplored. And that's the problem that we work on. We want to understand our ocean better. We want to inspire and connect people to our oceans. But I wanted to start a little bit with where I came to the ocean and came to this work. So my personal story, we're clicking. Sorry, I've lost my cursor. Stand by just a minute. There we go. My story begins in the great oceanography state of Idaho, home of potatoes and not a lot of deep sea corals. The Boise Valley here is a beautiful place with rivers and mountains, but very little ocean. This is where I became a diver. I got certified to dive in a reservoir where I saw 7 tires and 1 fish. And despite that, I was still thrilled and wanted to go down this ocean path. And for me, I think there are a lot of little kids that love the ocean. My goal is that all of us across our life never lose that. But I was that little kid. Here I am as a first grader, dressed up as the water cycle. Those are my dad's art skills. They're pretty awesome. Not mine. And I'm still doing now what I was doing then, as I think about it. So for me, the ocean was alive in library books. It was alive in storybooks. But I had this idea that I wanted to do something involving the ocean. So I figured science was the thing. My perspective was that I thought the only people who worked in the ocean were marine biologists. So I was like, well, I guess I will need to become a marine biologist. I went to Oregon State University is where I studied, further advanced my diving career, learned pretty quickly that I wasn't sure I wanted to be like a capital S scientist, but I wanted to be on the team of science. I wanted to be in the ocean. I wanted to be helping teams go out there and helping people understand the ocean. My first job out of college was as an underwater garbage cleaner upper. I worked in Papahanaumokuakea Marine National Monument collecting derelict fishing gear off of shallow coral habitats that were incredible habitat and important habitat for endangered Hawaiian monk seals and sea turtles. This was a free diving job. We could talk all about it later if you have questions about it, but essentially hold your breath, go down, saw nets off of corals and haul them out. Very tiring work, very great work. Then I moved up from, regular garbage cleaner upper to underwater vacuum cleaner upper as another job using scuba diving. I worked on an aquatic invasive species team. So this is a team where I studied very large, like tumbleweed algae that would grow over and take over coral reefs. This was from an intentionally conducted science experiment in the 1970s, where the invasive Capophycus algae, if you've eaten ice cream, if you may use makeup products, many of those things come from this particular type of algae, which is grown around the world. But in this case, a test plot was not removed, and it is taking over the largest bay in Hawaii. So I spent a long time vacuuming underwater, diving, thinking about how we could help the ocean, how we could get involved in it. My career then continued in the diving world. I started doing more advanced diving. This is cave diving. And somewhere right around here, when I am underground and underwater, my family in Idaho was like, girl, what are you doing? Why are you underground and underwater? And what is this career path? And as I was having these incredible opportunities, I realized that I really wanted to bring my friends and family along with me, maybe not necessarily like into that cave, but on these places and to care about these places. Why do we want to go into caves? Because they can help us understand fresh water, because they can help us understand interesting species that are there. They can teach us about psychology and human mind and challenge. There's lots of reasons you might want to go there, but just like me posting a picture of it wasn't quite enough. And that's where my career really spun and took a turn into not only doing these things, but like, how could I share them? And how could I start to do that more meaningfully? In this science communication pathway, I've had a lot of really fun opportunities along the way. One place you can do science communication is aboard in the tourism industry. This is the National Geographic expedition to Antarctica, where I got to both scuba dive and assist camera folks getting into the water safely. So using my diving skills and my boating skills and my training, and growing my science communication, linking people to these places and why they're important. Later on my science communication journey, I became a submarine pilot of the world's largest passenger submarine, where on a very special Christmas many years ago, we took over 600 people into the ocean for their very first experience in one day. I was starting to think about scale. How could we reach more people with the ocean? How could we connect them in these ways? There's early days of kind of some social media and some video production, and just getting more and more excited about this. And that is the first time that I encountered the team that I work on now. I came to sea with Ocean Exploration Trust, who go into the ocean supporting science and have a dual mission to share that with the world. So that's me holding onto the tail of ROV Hercules, remotely operated vehicle Hercules, who will become a star of this story and show as we go on a little bit. Here in my role, I now share a lot about the ocean. We live broadcast around the clock. We share with millions of people, billions in the press, but also, get to connect youth to our oceans. So many parts of that. And I also lead a series of at-sea internship and fellowship programs. So really helping advance other people into their careers. So for me, this feels like a real natural progression. I'm still supporting how we learn about the planet, but I'm also inviting a lot of people into these spaces. And I want to give a special shout out to Anshika, who's here, who is one of our internship alumni. And I'm super excited that you're here. Thanks for coming. So here's the story. I've been working with Ocean Exploration Trust now for 11 years, conducting expeditions all over the world, and those are hosted from exploration vessel Nautilus. So we own and operate this ship. It has been all along the California coast. We have hosted over 160 expeditions around the world, from the Black Sea and the Mediterranean, across the Atlantic, the Gulf of Mexico, the Caribbean, and then since 2015 in the Pacific, working as far north as northern British Columbia, and as far south along the continent as Ecuador, as far south in total as American Samoa, and working our way west across the Pacific. Our expedition season, each year we host somewhere around a dozen expeditions that go around the world. This is our 2023 expedition season, which has been going for the last 260 days and wraps up in 2 weeks. So we send the ship to these different locations, all in pursuit of going to places that we still don't understand about the planet. And if there's the first time thinking about the deep sea, I like to kind of take a very big step back about what is the deep sea environment in a big way, many of us, maybe all of us are in the United States. And so I like to use this example first, that if we think about the US as a country, most of us think about the dry and dusty parts of it that we live, that we could drive our car or go and visit with an airplane. But all countries, including the United States, control an exclusive economic zone, which is like a donut around your coastline of 200 nautical miles, sometimes for international legal reasons, slightly more, slightly less. But basically like a giant circle around the country. So when we think about the United States, over half of the United States is actually underwater. And for most of that, we don't have maps of it. We are still at these very early stages of understanding what's there. And I really like the role that we have as explorers and as an exploration team, is we're kind of like step one on the knowledge chain. It's a really hard decision to decide what you're going to do as a resource manager or as a National Marine Sanctuary manager if you have no idea what's there. And it's hard to make wise use of all of these natural resources and cultural resources and indigenous knowledge and spiritual connections to these places, all the things, reasons why we love an ocean, to care for them. Another thing I like to think about at the deep sea, especially coming from a scuba diving background, is how deep we're really talking about. Now, I'm up near Seattle, so please forgive my Seattle Space Needle ruler here, but it's a pretty nice even number, around 200 meters tall. We can take our recreational scuba diving limit and stack that next to it to kind of like get our scale of it. So I still actively scuba dive. I love it. But most of the places we're going, scuba diving wouldn't get us to the depth where we like check our gauges on the robots. So we're aimed at going to like deep and accessible places in the ocean. So if we want to stack up our Space Needles and think about the deep ocean, one Space Needle will get you down to like almost where your light is starting to go out as far as our powered human eyes will go. It takes, by the time you get 2 down, like we're not seeing any light at that stage. When you get 5 Space Needles down, that takes you to 1,000 meters. That takes you to where we technically call the deep sea beginning. We can keep stacking them up. The average ocean depth is about 3,500 meters, which is quite deep. And then we can stack our Challenger Deep, or our Space Needles, all the way up until we get to 11,000 meters. Which is the deepest place in the world's ocean. So when we think about the deep sea, our robots will dive to 4,000 or 6,000 meters, which will get you about 2/3 of the way across the screen. And there's a lot of very deep and very dark ocean that we go to. And when we want to go explore these places, we have to start by making our own maps often. So this feels like kind of insane every time I give a talk about it, but we are still at the stage of like finding mountains. There are hundreds of thousands of mountains called seamounts in our ocean that we don't really know where they are, and we don't have a clear picture of them yet. And the way that we can most effectively make maps of the ocean is using sound. So borrowing from the wisdom of whales and all these things that already exist brilliantly in the ocean, a multi-beam echo sounder is what's on the bottom of our ship. I think about this like a fish finder on steroids, right? If you've had a fish finder on a recreational boat, it sends one ping of sound down, measures how long that takes till it comes back. If it takes longer, it's going deeper and it bounces back to you, and you can tell how far away something is underneath you. This sends 684 pings in a fan down beneath the ship and lets us map landscapes at a time. Thinking about, again, I was a biologist by my training, so I think about that sometimes when we get started here. How are we going to relate to this? Like, I could open up my phone and I could find the dive shop, right? And all of you could too, maybe the first time you visited. Or in the neighborhood, you could find out where you might want to go to lunch after your dives. Or, we could look at this map, and studying it like biologists, I could look down at that map and I'd be like, where are the population centers? Where do they travel? What do they do during the day? And I could answer a lot of scientific questions about this. But when we look at maps of most of the deep ocean, the resolution that we have right now looks more like this. It looks more like Lego blocks. It looks more like these like big blurry versions of what the deep ocean looks like, which I'd have a very hard time finding the dive shop in this map, or a dive site, or where I might want to go find some food or meet my friends or any of the rest. So there's this massive global campaign right now to map the world's ocean. There's an ambitious goal to do it by 2030. I think that's ambitious, but we contribute all of our data, and there are a lot of other industries and corporations and science groups that are working on that. Just past 20% of the world's ocean at this point mapped. To give you another look, like I want to put on a scuba tank at this place. This is the Revillagigedo Archipelago, a popular dive site. But when we look to the depths beneath the places we could put on a tank, you can see the difference between the dark blue blurry, that is that Lego block resolution of the ocean, and the multicolor, the rainbow colored data, which is the resolution and the detail that we get from multi-beam mapping. So I, again, biologist, falling in love a little bit with shapes of the earth and a little bit of geology. And it's something I love about thinking about the ocean as a whole, is the way these intersect. Because I'm like, look how cool this mountain is. There's little eras, like little volcanoes that almost erupted to the surface or at different stages of this place forming. And that's for depth and scale, we're looking at about 4,000 meters on the dark purple, all the way up, rising to the so many incredible shapes of the planet. This is a fracture zone in the Pacific. This is where you can think about like the skin of the planet literally like stretching and fracturing as it moves around, and we can reveal those shapes, which start to give us clues about where we might want to go and look closer. When we go closer, we start to deploy remotely operated vehicles, ROVs. We have a couple different teams of robots. What's great about remotely operated vehicles versus human occupied vehicles is the safety factor. Robots don't have to eat or sleep or go to the bathroom. Once we send them down there, they don't run out of batteries because they're connected constantly to the ship. And that lets us stay down on the seafloor for days on end, exploring and covering a lot of ground, seeing a lot of things. If folks are technology interested, we could talk about it later too, but we also use our ship as a technology test platform. So we've brought a lot of autonomous vehicles and systems to sea with us the last, I'd say 5 years, to really figure out how we do this faster, right? 95% of the ocean, if you've heard that over and over again, I've heard that number for years and years of my career. We have to start moving this faster if we want to understand and care for our ocean. Now, have a bunch of videos to show you of things that we see, but I also want to share that this is how you can get involved. One of the special things about our ship, like I'd have a fun job if I went to sea and then I came back and I was like, hey, we saw stuff. It was great. But what we do on Nautilus is we use a technology suite called telepresence to mean that you can be on the seafloor in real time with us wherever we are around the world. And that's made possible by these tethered vehicles. They send all of the data to the ship. We rent a satellite in space. We rent and commit our own bandwidth the same way like the Olympics do or the World Cup that you'd watch. We send those feeds down to Earth and then distribute them out on the internet. So when we see something spectacular on the seafloor, you can be watching it on your phone, on a monitor in the dive shop, in a classroom. Anyone, anywhere can now authentically be part of exploring the ocean and about moving this forward, which I think is really exciting. All right, here's what we came for. Cool things on the seafloor. So one of the best parts of being on this team is that I don't just have to be the biologist or the geologist. When we go to places we've never been on the seafloor before, we don't know what we're going to find. It's kind of the key part of being an explorer. And so it means that we get to work at these intersections. So in the upper left, that is a hydrothermal vent. It is a place where the skin of the planet is breaking open. Seawater is getting down, superheated by magma beneath the rocks. And what you see, that black smoke, is a superheated water dissolved with minerals shooting up out of the seafloor. Now this is like flying in and among skyscrapers with your little robot-sized car. I sometimes imagine in a city what like a bird must feel like navigating through skyscrapers, and the closest I am ever going to get is diving in hydrothermal vents here. Those are superheated liquids, hundreds of degrees. They'll totally melt your robot, and yet they are covered in life and only discovered less than 50 years ago. This is now our best understanding of how life started on the planet. It is from the ocean, and we're still learning all about it. Again, as a biologist, like I have to love deep sea coral in your lower left. This is a coral that is over 15 feet tall, and we think that it is probably over 2,000 years old. There are corals in the ocean that are 4,000 years old as an individual coral colony, which means that like that coral started growing before the Babylonians invented math, right? So some incredible long history in our ocean and impressive places to care for and protect. If you like history, this is right off the California coast. In the upper right, this is the aircraft carrier USS Independence. It's a World War II aircraft carrier that was intentionally scuttled out near the Farallones. It was used as a target during our atomic testing period after World War II, and then it was thrown away. It was deep sixed, and one of the most powerful things I experienced being part of that exploration was just getting to share with generations of kids about how like this used to be an acceptable way to put something away, is to put it in the ocean, and how much our relationship with the ocean has changed since then. And then, you know, being an explorer means sometimes you just have absolutely no idea what you'll come across. We were diving, doing an exploration in the Monterey Bay National Marine Sanctuary. This was the last day of the expedition season that year. It was getting very close to Halloween. It was kind of a spooky feeling on board. And we're transiting across this open mud flat, mud, 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 mud. Some of the bottom of the ocean looks like mud. And then we just came upon this mound of a whale fall. This is a skeleton of a baleen whale. And this is the dinner bell absolutely ringing in the deep sea. So you see there octopus, eel pouts, bone-eating worms, all kinds of these things that feel very supernatural to me, but are totally like the, you know, these are the neighborhoods of Earth. These are actually the dominant neighborhoods on our planet while we hang out up here on the dry and dusty part. So this was a really great surprise, and, you know, definitely one of the like spookier surprises the ocean has ever shown me.
Hey, Meg.
Yeah.
There's a question about the radioactive from the barrels in the
Yes.
Farallones. Is that creating a problem?
Yeah, it's a really good question. We had there's a couple elements to this. The barrels that were on this particular wreck, no, we actually outfitted the ROV with a radioactive, you know, like an ion detector that was equipped for the pressure and the depth. It was a very specialized piece of equipment because we were interested in that. Salt water is an excellent buffer. It's both excellent at binding the ions that we'd be concerned about, and also just the density is very effective against the types of radiation that were used on the ship. This ship also, you know, just to give you the super nerdy deep dive here, at the end of this military exercise this was used for, the kind of leading theories at the time thought that navies were obsolete, that there was no use for a navy anymore now that there was an atomic weapon. And there was this big question of like, if a ship gets irradiated, will it be irradiated forever? Because we didn't know. And this ship was taken into San Francisco and sandblasted. So massive chunks of the ship had been broken away, turned into fine dust, and put into the bay in San Francisco before it ended up being hauled away, as they like learned about radiation at the time. So there were barrels of low-grade radioactive waste, meaning things like gloves and shirts and clothing, encompassed and closed and put inside the ship before it was sunk. But we didn't detect any of that. I do think I won't speak for because I'm not an expert on, but I do know that in addition to the DDT barrels that have been found in Southern California, there are some additional types of waste barrels that have been found, and I don't know the outcome of those barrels and kind of how they, just what that cleanup may look like or what that impact may be. Yeah, really good question. It was a huge question, and we live streamed this all to the world, right? And so we've got to meet people everywhere that they are on the internet, which is a fascinating thing. And we can talk about that if you'd like as a science communicator too, as we're like fastening this very large detection, you know, basically detector onto the ROV, and mitigating a lot of fear for people about what we may be coming upon or what we may be releasing. Was definitely an interesting part of that mission. A few other things that I just wanted to show, that one of the things that surprised me, so I'm a marine biologist by training, and I never took a deep sea class during that training experience. So the deep sea I love it because the deep sea teaches me, right? We learn all about these things all the time. But one of the things that consistently impresses me is how colorful the deep ocean is. And we find these reefs, and we even know this to be true as scuba divers. Like as we go down, the second you turn on that light, so much life, so many unique adaptations and colors. And we see that pattern continue into the deep sea, which is really interesting. And there's many pinks and reds and purples, which in that color spectrum kind of means that these animals would effectively be invisible, right? They wouldn't be reflecting back any of that red light. And so that's a stunning part about diving with ROVs in the deep sea is just watching these landscapes come to life as the two ROVs working together move up the landscape in here. Now, I wanted to give a couple more classic California examples of things that we had found. And one is the octopus garden. And this is a story that I'm really proud of, how the ocean community works together. And my team really represents step one on a lot of that. So if we find something exciting, more teams will return to this place. This was an expedition where we were flying along Davidson Seamount, which is offshore of Monterey, inside Monterey Bay National Marine Sanctuary. And we found this little dot that looked kind of like a bowling ball, this kind of mauve lavender little bowling ball shape. And then there was another one and another one. And as the ROV flew along, all of a sudden we realized they were all over the field of view in all of these cracks in the rocks along the slope of this mountain. And there were thousands of them. We estimated over 2,000 of these brooding octopus. Now, one of the things, again, great thing about being an explorer is like you go to the thing that is the most exciting. So when you find this, you stop the ship and we, zoom in and spend time and take measurements. And coming out of these cracks along the flanks of Davidson Seamount was shimmery water, kind of like a mirage on a hot day off of a parking lot. Now, shimmery hot, it doesn't have to be scalding to be warmer than most of the deep sea, right? Most of the deep sea is about 34 degrees, dark, and the water coming out of these cracks, we found out to be in the 60s. So the nice scuba diving temperatures that you all have there. Now, this was the end of the expedition season, literally one of the last dives of the year, and we found this, and we share all of our data publicly and in real time. And so this discovery spawned a series of return expeditions. So the HOB Alvin has been here, the Monterey Bay Research Institute and their ROVs have been here. We had the chance to return. The Woods Hole Oceanographic Institute returned. This is the first aggregation, the first viable aggregation of brooding octopus ever found in the US. The first one ever found in the US, the first viable one found in the world. There is another place octopus brood like this, but it's in an area where there is so low oxygen, they don't actually think any of the babies hatch there. So Davidson Seamount had been visited and has had research expeditions since the 40s and 50s to it, and yet one more revelation of something incredible happening here. You see this super cool posture that the mothers actually lay over top of the eggs so they can ventilate and push fresh oxygenated water to the eggs. And then they do that curling pattern to take debris and mucus off of their own bodies and off of the eggs. So just an absolutely incredible thing. This came up back in the news again, although it's been 5 years since we first found it. Again, there have been follow-on researchers who have returned and who are now publishing papers with results, knowing things like going back to a place like this over time. What is the period? We think it's about 4 years that these octopus brood on their eggs until they hatch. And knowing things like the flux and the temperature and the conditions, just an incredible site right off the California coast that we didn't know was there before. Some of my other favorite things about the deep ocean that I want you to know is that there are lakes at the bottom of the ocean. This is an environment called a brine pool, and it's from the Gulf of Mexico. This is a place where super salty water gets trapped inside depressions in the seafloor. So you could think about like pocks and basins. And in the history of the Gulf of Mexico, it has dried out, it has reflooded, it has dried out, it has reflooded, and there are big, big deposits of salt underneath the surface. And so when regular ocean water interacts with salt underneath the mud, you get super, super salty water, salty enough that it can actually kind of mummify creatures like those very sad crabs that had fallen in. These are also places where we often get natural gas seepage coming up. So they end up being these total extremophile environments, like you might see at a Yellowstone hot springs, or they're the kind of environment that people like to study for outer space to understand how life figures out how to live in these super, super hostile kind of conditions. Again, I had done an entire degree and never learned about a brine pool and a brine lake. And you can see this rim of mussels, just like in the intertidal, and just an absolutely incredible type of environment right beneath our noses. One of the things we get to do a lot in our work is not necessarily discover new species, yes, but we also get to discover when we find species in places that we don't expect to see them. Looks like that video isn't playing. All right, we'll just click over to the next one. But this is the video didn't play, apologies, but this was something we get to call a range expansion. And a range expansion is super important. And I'd say, I'd argue, and I'd take that all day of, is discovering a new species important? Absolutely, because it's exciting and it adds to the inventory of what we understand about the planet. But I'd also say that knowing where animals live right now, particularly in the context of climate change, and if we want to be understanding adaptation and change in the deep sea, knowing where to find things is also really important. This was, we were along in the Central Pacific, diving along a deep sea seamount, when we came upon this kind of alien face hugger looking beautiful creature. I'm a tall person, I'm almost 6 feet tall, and this creature I would have to look up at. I'd be about as tall as where that stalk gets wider. This is about an 8-foot tall giant sea pen, which is related to a coral. They have the same kind of polyp face, but this animal makes its entire living by capturing marine snow and food out of the water column. And it stands up tall like that, filtering food from the bottom of the ocean. Now we know this animal, well, I didn't, but experts around the world do. And because we can bring any expert in through the live feed at the drop of the hat, we identified this as a Solembulula sea pen. And it turned out Solembulula, we knew it lived in the Mediterranean, and we knew Solembulula could be found in the Atlantic, but it had never ever been seen in the Pacific. So we now know Solembulula lives at Johnston Atoll in the middle of the Pacific. Does it also live off the coast of California? Very possible. And this is one of the things that just thrills me, is that as we understand more about the ocean, more often than not, we end up with more questions than answers, but this kind of can drive and feed this opportunity to go on. I want to share this just to not, just to super level set about like the efficiency of ocean exploration at this moment. So what we're looking at is a bathymetric map. It is a massive seamount called a geo that has a flat top like that. Sometimes they're called table mounts. And those tracks that go down and back up are the duration of a dive for us. So that's how far we could get in, I know each of these are about 24-hour dives, 24 to 36-hour dives. So what you're seeing is the ROV's descent to the seafloor, maybe about 5 or 7 kilometers of track on the seafloor, and then an ascent again. So we are at the stage of like hurrying to understand the deep ocean and to get a representative vision of what most of the seabed looks like. But there remains so much mystery. And this is one of the things that I think is most exciting about working in the science communication side of this space, is that there is infinity more work to do for more little kids dressed up as water droplets who have visions of loving and caring for the ocean, right? And I get to be the one coming and talking with you tonight, but everything that I've shared would not be possible without the massive team that makes this happen. There have been over 1,400 people that have sailed on Nautilus. and they come from all over the world, and they have all kinds of interests. They aren't just marine biologists. In fact, very rarely is someone like a very specific marine biologist of one type. They're geologists, they're chemists, but they're also chefs, they're filmmakers, they're educators, they're students that come to sea with us, professional mariners, like runs the gamut of what an explorer career looks like and means. And I just want to share with you a few of the ways that you could get involved, or if you think someone else would be excited about this work, how they could get involved. In addition to our live stream 24 hours a day, we also have a dedicated broadcast studio on the ship where we talk directly to classrooms. We schedule them free. We schedule them around the clock. So whatever time zone you are in the world, they're 30 minutes long, and they're really just an opportunity to get to meet an ocean explorer and talk with them. We host these in any language that anyone on board speaks, but we also specifically host them in Alela, Hawaii, the Hawaiian language, as we're in the Hawaiian archipelago right now. We have over 200 education resources. So if you have kids, if you have friends with kids, if you have grandkids, if you've got like anyone in your life and Christmas is coming up and it's time to like have some activities, you can check them out anywhere from like dedicated classroom resources that are national standard aligned to like fun things to do with frosting and graham crackers to learn about tectonic plates. There's coloring pages, there's activity books. I'm thinking about holiday baking, obviously, but there's a cupcake recipe which will turn your cupcakes into bathymetric maps by making Rainbow Mountain seamount cupcakes. There's all kinds of really fun activities, and we, for all ages, really designed to introduce people to the ocean and to get them inspired about finding their own path and their own passion in linking into this. I'd invite you to check out the live stream as we're just a couple of weeks from ending the 2023 expedition season. If you would like to be part of the 2024 expedition season, I also have a couple more opportunities. We have a patch design contest open right now for students. So young people ages 5 to 18, if they want to design the emblem for the team next year as we go further into the Central Pacific, we send out big prize packs to the students, and everyone will wear your patch and sticker for the year. And then we also have at-sea programs. So if you're an educator, and that includes community educator, artist, journalist, or if you are a student, these are paid programs. So we will fly you to the ship, you will train with our team, come home as an authentic ocean explorer, as part of our team and as a role model for exploration for others. So highly encourage folks to think about these opportunities, and we'd love to have you. Just as we wrap, and I know this is recorded, so this will be like the fun debut, but I want to share a little bit. I want to share our 2024 expedition season map with you. So as we wrap up the 2023 expedition year this year, we're already looking ahead and planning ahead. So if you want to go on an ocean exploring journey with us next year, maybe without the flight time, I'd invite you to be online with us on any of our 6 social media channels or on Nautilus Live. And take a journey to American Samoa, or maybe to Palau, or maybe to Baker and Howland, which is a part of America that you may have never heard of or seen before. So when I think about exploration, it's going to take all of us to move this number 95%. It's going to take this next generation that are both incredibly have great tools at their standpoint, or at their fingertips. Like we're going to have advances in the technology in our autonomous systems and our computing in the ways that we can go and sense and understand the ocean, and also the great imperative that when we spin this globe around, this earth around, there are lots of places that are blue, and it's possible to look at the entire earth and see very little land and mostly just ocean. So as we move this number 95 down lower and lower, it's work that's going to take all of us, and it's work that I think is the great opportunity of our lives to look out for and learn about this planet. So that is what I wanted to share with you, and I'd be happy to answer any other questions or talk about anything else you'd like to.
Sure. Thank you, Megan. Hey, really fun. And we do have a query. I think it's Lainey. So just come on off mute if you want. And Lainey, you can go first. Lainey, if you're on mute. Yeah.
Sorry, what was that?
Go ahead if you have a question.
Oh no, I was reacting. I had the hands clapping reaction.
Oh, okay, sorry.
You're
So
fine.
I was curious, if I want to go on one of these, what's the commitment if you get selected? Is it pretty competitive to be selected for?
Yeah, yeah, they are competitive programs for sure. But I will share with you the same advice that I share with all students, that I've never ever gone and like knocked on somebody's front door and been like, would you like to be a deep ocean explorer, and brought them out. So I always encourage you that if you have a passion for this work, to apply, because we're looking for candidates with all kinds of qualifications, and there are lots of different ways to get involved. So every year our season is made up. There are maybe about 200 different people that'll sail on Nautilus in a year, 49 at a time. So some of those are our staff. Ocean Exploration Trust only has about 18 full-time employees. Many of those are contractors. So folks could contract with us, and that's every single team: professional mariner, filmmaker, ROV pilot, scientist, anyone along the way. And then there are ways to get involved as a student, as an educator, those different ways. We generally go to sea for expeditions are between 3 and 4 weeks, especially when we're out in the Central Pacific. We have great food on the ship. Our professional chefs cook every meal for us, and cookie hours at 3 o'clock every day. So it's highly unnecessary, but very good.
It sounds like a trip of a lifetime, quite frankly.
Yeah.
How do you get funded? I'm curious.
Yeah, good question. Our primary expedition funder right now is NOAA's Office of Ocean Exploration. They have the federal charge to understand the U.S. waters, which over half of is the ocean. We're part of a cooperative institute, which is, I think about it a little bit like a think tank for ocean exploration. We competed for this prize 5 years ago, and put together a team of technology specialists and innovation specialists to kind of say, like, how far can you move the needle in 10 years on how technologies work together and are optimized for sea, how we're innovative, how we're more intentional about involving community, and how we can bring that work together. So a lot of those expeditions are funded that way. We also do have some expeditions that are funded by dedicated partners. Like there's a group in Canada called Ocean Networks Canada, who have hired us to help maintain their offshore science equipment for a few years. So we'll do work like that. But we also, our education programs and our real inspiration model is funded by philanthropy, by grants, by donations.
Wow.
Little of everything is the answer.
Sounds like it. Is there a place that you're looking forward to going to that you haven't been yet, upcoming?
I'm extremely excited to go to Palau. So the last few years we've been working within the US EEZ, and I'm really excited to get back to some international work. I guess I technically have been there. I got to go this year in October as part of some of our partnership meetings. We go, and our goal is always to be science in service of the place, addressing the highest priorities and needs. And Palau is you all may be familiar, but for those that aren't familiar, Palau made the very impressive and like full leadership commitment that they placed 80% of their national waters inside a national marine sanctuary, in the Palau National Marine Sanctuary. It's the highest declaration of any nation in the world, and has really been a biodiversity leading voice in that way. And when you get to the deep ocean in Palau, they have almost no data. They have extremely limited data based off of just a few research opportunities and opportunistic groups who, some have the model to share data and some don't. And so we're really excited to go there. I'm really excited to go there, both as a diver to love and experience this spectacular shallow ocean place, but also to really be able to provide the data to reveal what is, a a spectacular place. They have they have a trench, so they have some of the deepest ocean in the world. They have some of the highest biodiversity in the world. They're in a transitional zone between major currents. So we know that they have just this incredibly special part of ocean around their country, and I can't wait to reveal it, share it with them.
Cool. Again, if you want to ask a question, you can come off mute or put it into the chat. Happy to entertain that. And you mentioned that you have an intern. So what can you tell us about your internship program?
Yeah. Our internship program we have 5 different tracks of internships on the ship, and they embed with different operational teams. So we run an ocean science internship, a seafloor mapping internship, a navigation internship that we offer in partnership with the maritime academies and the service academies, a video engineering and filmmaking internship, and an ROV engineering internship. And I'd say the special thing about these is you are in the role day one. So we use 2 ROVs together as a team. And if you are an ROV engineering intern, you are flying ROV Atalanta when you get to the ship. And so you jump right in. If you are an ocean science intern, you're a data logger and you're processing samples and working with them in the lab, making the initial observations that are shared all over the world. Video engineering interns are controlling the cameras and the broadcast systems. So they're paid programs. You can apply anytime from community college to graduate school, including early career folks. So we know, certainly if you're watching this back and if you were a COVID graduate, the last few years have been wild as you've launched your career. So you're welcome to apply as well to the program. And I think the most special part of it is that close embedded teamwork. So our ship is really built to be a teaching ship, a teaching and learning environment. So we work 24 hours a day on Nautilus, and the way we accomplish that is by dividing into a 3-watch rotation. So we all could decide here which would be our favorites, but there are 8 to 12s, 8 a.m. to noon and 8 p.m. to midnight. There are 12 to 4s, midnight to 4 a.m., noon to 4 p.m., and there are 4 to 8s, 4 a.m. to 8 a.m., 4 p.m. to 8 p.m. And so every team sort of has that triplicate model. And one of those will be an intern, maybe having their first experience at sea. There will be a middle role, kind of a near peer mentor, an early career person who has maybe grown from the team and is there, and then a senior mentor who may have been, working in this environment for decades. And so I'm really proud of that model, and I think it's really, really effective to help people see the possibilities and get embedded in this experience in a really scaffolded but authentic way. No one's can't be sitting back and watching in our internship program. You're going to be right in it.
Sounds exciting. Yeah. What other questions do people have?
I just so appreciate you all coming. I know it's the holiday season, and so it does mean the world to me that you would share your time with me and want to learn more about our work and learn, share a few stories of some adorable deep sea, friends that share the planet with us. So really appreciate the opportunity and the invitation.
Yeah, thank you so much, Megan. Really appreciate it. So, and if you guys have any other questions, we can get a hold of Megan and we can follow up with her if you like. And just thank you so much for your time. The work that you're doing is amazing. So, and the word, yeah, really, really great stuff.
Awesome. Thank you all.
With
Keep
that,
diving.
I just want to remind you guys,
beautiful warm water for me.
That's right. So, and certainly anytime you're down in LA, Malibu area, come see us. Yeah, for sure. We'll take you diving.
Count me in.
So,
Count me in.
And thank you so much for your contributions and everyone for coming this evening. I know you guys are all busy with holiday plans and stuff. So we'll be back in January. If you have any need for anything, certainly let us know. I'm going to go ahead and stop the recording if I can find it. Yeah. Cool. And